Good girl. 9IA, moving things and forces and movement. So on this first page, moving things, they're using the example of moving large, heavy objects to get you to start thinking about forces like friction and air resistance. They also want you to start thinking about energy, where we get our energy from as humans, not food, where the energy in that food comes from, all the steps back, all the way to the beginning. What starts that food chain off? What is at the very beginning? Hint, think about plants and photosynthesis. So we get to page 2 here, and they are discussing reducing friction by using rollers or wheels. Something we have to get straight in our heads is what's happening when forces are balanced versus when forces are unbalanced. So if we're moving an object and we realise that the forwards force on the moving object is the same size as the amount of friction, then the moving object will be moving at a constant speed. The forces acting on that object are balanced. If the forces become unbalanced and the force of friction is stronger than the forward force, then that object will start to slow down. But if they are unbalanced and the forward force is stronger, then the object will start to speed up or accelerate. 2 other ways that unbalanced forces will have an effect on an object: changing the direction that it's traveling in and changing the shape of that object. So you can think about how unbalanced forces might change the direction of a moving object. Maybe the strength of wind on one side of the sails of a ship is stronger than on the other side, so the ship will change direction. And in the book they have an example of something changing shape due to unbalanced forces. They talk about a horseshoe being hammered. The force of that hammer striking is stronger than the force that the horseshoe exerts on it in return, so the horseshoe gets bent out of shape. So we've considered reducing friction, balanced and unbalanced forces, and now we're thinking about the forces acting on boats. Okay, start having a think about 4 forces that might act on a boat moving through water. I bet you've got at least a couple in mind. So we've got air resistance hitting the sails and the front of the boat. We've got upthrust from the water pushing upwards, holding that boat on the surface of the water. We've got the weight of the boat pushing down into the water, because weight is a force, don't forget. We've got water resistance too, as well as air resistance, pushing back against the boat. And we've got that forward momentum, that forward force, probably the wind pushing on the sails, pushing that boat forward. So there's a few to be thinking about there. Now let's jump back to balanced and unbalanced forces. Keep this in mind when we're considering how the boat moves. To keep that boat moving forwards, what do we need? We need the water resistance and the air resistance to be less than the strength of the forward force of that boat. We have a bit of a problem with boats, and that is that as the speed gets faster, the water resistance increases. So sometimes if the sails aren't large enough, we hit this maximum top speed that the boat can't go past, even with all the wind in those sails, because the water resistance increases and increases to match it. All we can do there is increase the size of the sails, increase the wind, pushing the boat forward. And perhaps if the seas were calmer too, that would also give us more of a chance of moving faster on the water. Lastly, we just need to remember some key categories for forces. So we first need to remember what counts as a fluid, and we need to remember that air and water both count as fluids. And we categorize water resistance and air resistance as types of drag. And drag forces slow down objects moving through fluids. And that's it for that page.